So by now you'll be realising that paper 3 has a lot of practical questions on it, a lot of questions that are going to test your knowledge of your endorsement practicals that you've done and any other practicals that you've done. So here's one that came from PAG 6, again the aspirin, but this time looking at the practical side of it. So they give you some information about it. They've given you how it was made, which was the same way you made it. The aspirin is much more soluble in hot water than cold. They've given you some clues about the recrystallization. They've told you basically the solvent for recrystallization. You've got a percentage yield and you've got to make this much. So outline a plan to prepare this. In your answer, include the mass of the 2-hydroxy benzoic acid needed and the purification steps. So concentrate on making sure you have definitely answered these parts of it. So by all means you can say you're going to add all of this together and you're going to reflux it gently, but the things that are going to get you the marks are the things that they talk about here. So the mass that you need, you have your number of moles of aspirin that you want to make is 8.1 over 180, it's that many moles. The percentage yield calculation is actual over theoretical times 100, which for a 1-to-1 is number of moles of product over reactant. So if you rearrange that, you will get your number of moles of reactant is 0.45 over 90 times 100. So that is the number of moles that you are going to need. So that gets you, that will straight away get you up to 2 out of your 6 marks for answering that part. And then you need to have answered at least some of the rest of this to be able to get above 2 marks. So this is about how you're going to purify it. It will be a solid. Aspirin is a solid. So you need to point out that you would cool it and then you're going to filter it under reduced pressure or with a Buchner funnel. It doesn't matter how you explain that, as long as you explain and either name the apparatus or explain the technique there. Then to purify it, you need to recrystallize it, which means you dissolve it in a minimum of hot water. Then you cool it, then you filter it again under reduced pressure, then you rinse it with cold water or whatever other solvent it was if it was a different practical, and then you allow it to dry. And depending on how many of these details you get and how clear all of this is, you will get up to 6 marks on that one. So not mass spectrometry, TLC. You've got some RF values here and some melting points here. Student analyses the purity by TLC. The results conclude that it's impure and it's contaminated with a little bit of this. So when you draw your spots on, you should have measured that distance and made sure these are 0.3 up and these are 0.75 of the distance between here and here. They will be checking to make sure that those are about 0.3 of the way up and those are about 0.75 of the way up. So your impure's got a bit of both and then 1 spot for each of those. In terms of melting points then, this again, it comes from your practical work. Knowing that impure substances have lower melting points and they're over a wider range, more than 2 degrees C. So you can get away with anything up here that is below 140 and has a range that is more than 2 degrees C. So that's an example of what you might have done there.